If we turn our attention over to the sideboard here, on Thursday, the 16th of January, SWBA students will be able to use elimination to solve systems, section 5.3, okay? So we have this elimination method. We're going to learn about that today, what that is. At first, it'll be really weird, but I think you guys are really going to like it overall. It's actually my favorite method to solve these systems of equation. We learned graphing first, and that was just basically, instead of graphing one line, we graph two lines. And we just look where they intersect, or if they intersect. And then we just did substitution. We did that last lesson 2 days ago, as well as we did that today during our homework, where we say, hey, we just have to solve for a variable if it's not already solved. And we plug it into the other equation. I like that method a lot as well. My preferences are elimination and then substitution, personally. I like both of those. And we'll talk about when I like to do each of those and when I prefer to do one over the other and why that is. Okay. We're going to talk about this idea of elimination. So I have these steps for it, okay? So if you look at your notes, the first step there says line up your x, y's, and constant terms. Line up your x's, your y's, and your constant terms. Okay, we'll talk about what that means. And the second one, eliminate one of the variables by adding vertically. Show me with your hands what way is vertically, guys.
This way.
Okay, it's this way. Close, but no scar. Okay, this way. Okay, vertically is up and down. Okay, then it says substitute the value of the variable into one of the original equations. Okay, so this is after we solve for a variable. Then we're going to substitute it back in to one of the original equations. Does that sound familiar? Yeah, that's what we just did with substitution. Was after we solved for the first variable, we went back and substituted for the other one. And we write it as an ordered pair x, y. So the last two steps are the same as substitution. The first two is where we have a change there. Seth, if you're going to sharpen. Nope, okay. The first two is where we have the difference, okay? So it's all about how do we solve for that first variable? That's the difference. Solving for the second variable is the same in either method. You just plug it back into one of the equations and solve. And we've been solving equations like that for quite a while. So we're used to that. So let's talk about this idea of lining up your x's, your y's, and your constant terms, okay? So if we look up here at the board, and we see, okay, lining up. That means they're in an organized fashion, okay? So are the x's, are they all together? Like if we draw a line right here, if we were to draw a line right around these, you don't have to do that. But if we were to draw a line right around that, do we see our x's lined up?
No.
Okay.
Yes.
Yeah, we do. We see our x's all together. They're both first. And then we see our y's both come next in both equations. So our x's come first in both equations, and then our y's come second. And then I also like to say, let's line up our equal signs. Are the equal signs also lined up there, guys?
Yes.
Yeah. And then the constants, so the numbers without the variables, those are also lined up there. Yes?
Basically, you're just going to be like subtracting our equations by each other.
Kind of cool. So after we have these lined up here, we'll say, okay, we'll eliminate one of the variables by adding vertically. So what you do is you put a giant plus sign over here and an underline here. So just like before, if we had done the addition problem, let's say we had done the addition problem 9 plus 5. Well, you'd put this 9 on the top, the plus to the side, the 5 on the bottom, and the y underneath for the equal sign. Same idea here. We have this plus sign, and we have this equal sign down below. Now this time we're just doing 3 separate additions, really. We do x plus 5x. What is x plus 5x? 6x. And we say, okay, well, what's negative 2y plus 2y? 0. So I can put 0y, or just 0. The equal sign stays equal sign. And what's negative 19 plus 1?
18.
Negative 18.
Negative 18.
Okay, negative 18, thank you. And so do we really even need that plus 0y in there?
No.
No, okay. So we can really just have 6x is equal to negative 18. Now, we look at this and we say, hey, wait. Can we solve this equation? All of a sudden, we just combined the two equations through this elimination method, and we eliminated one of the variables, hence elimination. Okay, we're really clever with this naming, guys. Okay, we eliminated a variable, we got rid of the y's. Now we just have x's, and we have 6x is equal to negative 18. So we divide by 6, and what's x end up being?
Negative 3.
Negative 3. What do you mean, why is it still negative?
I said, why is it so negative?
Why is it so negative? You should turn that friend upside down? Yes, okay. Now what do we do once we find that variable? Plug it in where?
To the exit.
X is in either X in either of the top two equations, okay? We can pick which one, okay? Would it work to plug it into our new equation in the green here?
No, because you might have made a mistake.
No, we might have made a mistake. Also, is there a Y in this equation to solve for?
No.
No, but we need to go back and solve for Y. So we need somewhere where there's a Y. And now which of the top two would you prefer?
X, the one for the one.
The top one was single X, smaller numbers, right? Besides the negative 19, okay? So negative 3 minus 2Y is equal to negative 19. Add the 3. Oh, that was about 3. Negative 2Y is equal to negative 16. Divided by negative 2. And Y is 8. And we still write our answer the same way we would have before as an ordered pair. So we still write it negative 3 comma 8. And that's our answer. That's it.
So why are we learning this now? We didn't learn it earlier.
Yes.
Yeah, it's
So,
way easier.
so Lucas asked, why are we learning this now? Why didn't we learn this easier? Okay, we learned this earlier. Said like this is way easier. Chris is like, that's it. Like, come on, like we've been
Why?
doing more this whole time. Okay. Well, this is one of those problems that's perfectly set up for elimination. Not every problem will be perfectly set up for elimination. So not every one of them will be this simple. Okay. But this is why it's my favorite method.
Then we get mad.
Is because I think once you get the hang of it,
You're getting
I
mad.
think it's typically the simplest. Okay? I think it's typically the simplest, okay? But that also comes with the caveat of how is it set up. Okay, and we'll talk more about that in a moment. But briefly about it now. If you look at these two equations, when we added, we got rid of one of the variables. We eliminated one of the variables. What variable did we eliminate?
Why?
Why did the y's eliminate here? Why did the y's eliminate? Why didn't the x's eliminate?
They match. They perfectly lined up.
What do you mean they match? You said they're the same number?
Same
number but opposite.
They're integer.
Opposite signs. Very good. They're the same number but opposite signs. Exactly right, Christian. So they're both 2y and 2y, but one's negative, one's positive. And anytime you add opposite numbers like that, a negative and a positive, the same number, okay, we're going to get 0. So that's why that worked out there. So it was already set up for that for us, okay? We'll learn that it's not always set up for that, but we'll look at that a bit later. If we turn our attention to example 2 here, we have 2x plus 3y equals 6 and negative 2x plus 4y equals 8. So we go through our system and we say, okay, our steps. Are these lined up? Do we have our x's or y's or equals and our constants all lined up here? Yeah, we do. They're all in order. X's come first, y's come second, equals come third, constants come fourth. So now we say, okay, well now we eliminate one of the variables by adding vertically. So we put that plus sign and we make that equal sign there, they underline beneath. What is 2x plus negative 2x?
No X.
No x, 0. Do we even have to write it?
No.
No. Okay,
We can if we want to.
but you can if you want to.
I don't.
What's 3y plus 4y? 7y. What's 6 plus 8? 14. Okay. So now we have 7y equals 14. We look at that equation, we're like, heck yeah, this is light work. This is warm-up stuff, okay? We've been doing this since first semester. We've been doing this since last decade. Divided by 7. Can't stop, won't stop. Y equals 2.
I think you're really bothering Kelly with that.
Yeah. Oh, this is good. I'm happy to hear that, Kelly.
Sure, that's what that was. Yawn.
Hi, just tired of Mr. Costle. Nice to meet you. Okay.
I was waiting for it.
So, now what do we do with this y equals 2, guys?
Plug it in.
Plug it in, right? Into either of the top two equations. You guys have a preference?
Top.
Top one? Why, Chris?
Because it doesn't have negatives.
No negatives. Why else might we choose the top one? Someone else. Smaller numbers, okay? Those are both great options of why to choose the top, okay? So let's choose the top. 2 times x plus 3 times 2 equals 6. So that's 2x plus 6 equals 6. Bless you, must rain down afterwards. Forget.
Oh, thank you.
2x is equal to 0. Do we panic when we have something equal to 0? No, business is normal. Divide by 2. I say, wait, what's 0 divided by 2?
0.
0. X equals 0. So what's our final answer?
0,
I usually don't divide. Why would you divide?
What?
Why do you divide?
Like, why do I even do that math?
Yeah.
I mean, if you know...
You already know it's gonna be 0.
Yeah, if you know it's going to be 0, you can skip that step. That's fine. But that's the actual math that is there. You're just mentally going over it.
I think I prefer that.
Okay.
The iPad mode.
Yeah? Why do you say that?
It doesn't block my view.
Yeah.
You can like stand off the side and stay right.
Yeah. Is it... The screen is narrower. I don't know if you guys are noticing that.
Yeah.
Normally the screen for the board is up here. You said this is messing with your eyes? How narrow it is? Okay. I know that might be a little harder to see because it's a little more compressed is kind of my fear with it. But what do you say, Reese?
The watermark.
Yeah, the watermark isn't bothering me.
The-
I don't know why. That's because
Yeah, well, that's not part of the water. The green line is not part of the watermark, actually. That was an actual accidental stroke I made earlier. But, yeah, that's a watermark because of the program, the app that I'm using on here to mirror it. Because I'm also recording it right now on the iPad. The trick is to try and find a way that I can do it on the iPad while also recording so I can still upload my lessons. And so figure out how to do that. So it becomes the issue and the task there with that.
I think it's taking less time for you because you're not going over the standard colors.
Yeah, I have a nice little tap bar here with preset colors I made yesterday. That's kind of nice too, and I don't have to do the weight. That might be good. Yeah, but yeah, so I really do appreciate this feedback too, because these are things that I have concerns over or kind of trying to think about. Just because there's been an issue in the school with Promethean boards working all the time, and some teachers have real big issues with them where they just don't work, that kind of stuff. And so this is an idea of saying, hey, wait, is this a viable method that we could use in the school that would work out, that kind of thing. So, so I'm just kind of testing it out for the school and just kind of going to give some feedback on it after a while. Yes, Bailey?
I realize you don't have to do the game thing where you have to click up there.
Yeah, the calibration game.
Yeah, the calibration game.
Yeah, it's kind of nice because the iPad's already calibrated regardless of how I turn the projector. That's true.
Can you do it with your finger?
That'd be bad. Yeah.
That's too narrow. I'm pretty sure you can just zoom in and it'll make it.
See, I've tried doing zoom options, but what happens is then it cuts off like this part of it and this part of it at the bottom. Because like we were trying to play around with that before. I'm gonna try and play around with it more too. But yeah, I was having that issue as well before of trying to find a resolution that works on there. But yeah, thank you for bringing that up though. Yeah, Kenny.
Can't you also use your finger on that iPad?
I could use my finger on the iPad. Yeah, it's not quite as precise. Yeah. So if I'm trying to do like very specific strokes like in math, if I start using my fingers here, I'm gonna be more likely to make mistakes. And like my handwriting's already bad enough, so like fingers only gonna make it worse. Okay, Reese.
Is that one of those like $100 pens from the Apple Store?
Yeah, they're. I don't know how much these are anymore because this is the older model and they came out with a newer model. So I'm not sure how much they are anymore, but yeah.
You spend so much money on just a piece of plastic.
I mean, they're really convenient with the Apple products. I actually own an iPad and an Apple Pencil personally, but like they're just super convenient.
Is that the schools?
Yeah.
Oh.
Yeah. So this is the school's Apple TV, iPad, case, pencil.
School provides you with Apple TV.
For me to pilot it, yeah, they gave me the Apple TV for my room.
They're giving Mr. Costa the opportunity to try it out.
Yeah. Yeah.
If it works, then they'll probably put it in for sure the math department.
Yeah.
Because they use the Promethean board all the time.
Yeah. See if there's another option. If teachers are like, hey, we're done with the Promethean board, do you have another option? Oh, well, this might be.
Well, I like
Seeing if it's viable cost-wise, seeing if it works well, seeing what the bugs are, those kind of things.
seeing what classes have to read.
If what?
Yeah.
Yeah.
No.
Or like those little clip. Remote
Keyboards?
clip-on ones. Yeah. I
Yeah.
think it was called.
Yeah. Yeah. So there's all sorts of things that go into it. Okay, continuing on back to elimination. Alright, so sometimes you have to change the signs of one of the equations, which means we're actually going to end up subtracting instead of adding, okay? Before you can eliminate a variable. Okay? If we look here in the first equation, 3x plus 4y equals 18. In the second equation, negative 2x plus 4y equals 8 here on example 3. What do we notice? Even though things are lined up in x, y equals constants,
Or the y is the same sign.
the y's are the same number, but they're also the same sign. As Christian pointed out earlier, we need them to be opposite signs to eliminate. Okay? So we're going to have to figure out a way, how can we change one of those signs? Because the x's aren't going to eliminate right now, because they're different numbers. Okay? Even though they're different signs, they're also different numbers. Well, what happens if instead of, what else can I say? If I'm doing like 5 minus 2, what else could I call that?
3 minus 2.
Not 3 minus 2, but I could call it 5 plus what kind of 2? I call it 5 plus a negative 2, couldn't I? Couldn't I say I'm adding a negative instead of subtracting? Do I get 3 either way? Yeah. Okay, we said that all along, that instead of subtracting, you can say you're adding the opposite of it. You're adding the negative of that. Okay? So what we're going to do here, 2 boots. What we're going to do here is we're going to subtract this bottom equation. So instead of adding this bottom equation, we're going to subtract this bottom equation here. So I'm going to put a minus sign in front of that. And then what I'm going to do, guys, is I'm going to put this in parentheses. This equation in parentheses.
Yeah, because it looks like it's a double.
And because it looks like it's a double negative, and it also looks like that negative was just on the negative 2x. But what actually is happening is we're taking that whole bottom equation, and we're really going to just multiply it by a negative, or by a negative 1. So what we're going to do is we're going to distribute this negative inside the parenthesis. So I'm going to take this negative that I just put there to subtract instead of add, and I'm going to change this to a positive. Now if I now change that sign,
It's not writing.
if I now change that sign, okay, that negative 2x is going to have to become what? Instead of negative, it's going to become positive. Okay, it's going to become a positive 2x. This positive 4y now becomes what kind of 4y? A negative 4y. That was the reason we did this.
Negative 8.
And this 8 becomes a negative 8. Becomes an 8. Okay? Hey, stop. Thank you. Okay, it becomes a negative 8. Okay? Now, if we look through that, are we ready to eliminate? Are we going to actually get rid of one of our variables? Yeah, and that's what I mean, guys, when I'm going to say that quite a bit. Are we ready to eliminate? We're lined up, but are we ready to eliminate? Do we have a variable x or y to where they have the same number, different signs? Well, yes, now we do. The y's have a positive 4 and a negative 4. So we go ahead and we add to try and eliminate here. Let me try redrawing that. There we go. So what do we get for our x's? What's 3x plus 2x? 5x. What's 4y plus negative 4y?
No y.
No y, 0y. Do I have to write that then?
No.
Nope. What's 18 plus negative 18? 10. 5y equals 10. Do we like that equation?
No.
Oh, excuse me, 5x. Oh, man. 5x equals 10. Do we like that equation?
No.
What? You don't? That's like way easier.
Oh, I thought you meant like, is it an answer?
Oh, no, okay. Do we like to be able to work with this equation?
Yes.
Yeah, like this is the kind of equation we like to work with. Okay, so we divide by 5. I get what you're saying. I can understand how that would be, received that way. My bad. So x equals what? 2. So now are we done once we find x equals 2?
No.
No, we have to go back and plug it in. Now where do we plug it in? Okay, top or bottom. One of the original 2 equations. Now here's the thing. We don't want to do this blue stuff with a positive 2x and negative 4y and negative 8 because we could have made a mistake. We want to do the original equation. So if we were to choose the bottom equation, I'm not saying we will, but if we were to choose the bottom, we want to make sure it's a negative 2x plus 4y equals 8. We want to make sure it's the actual OG one.
Wait a minute.
Okay? We'd want to choose the OG one, not one of the new, not something we did something to. Now for that reason, it might be easier to choose the top, purely because we haven't even messed with that one at all. So it might be easier just to choose the top one in this case. But it really comes down to your preference. You guys said the top, so we'll do the top. 3x plus 4y equals 18, or 18. Plug in 2 for x. 3 times 2 plus 4y equals 18. What is 3 times 2? 6 plus 4y equals 18. Subtract. 4y equals 12. And what does y end up being?
What?
3.
Oh.
So our answer then is 2, 3. Kinda.
All other pairs look like
Okay, questions on that, guys? Okay, so if we go on to example 4, we say, are we lined up?
these.
Yeah, x is y is equals numbers. Constants, excuse me. Are we ready to eliminate, though?
No.
No, okay. So we have to think about what are we going to have to do again here? Seth?
Change your 2x. Make your bottom row negative.
Make the bottom one negative. Okay, change one of those signs here, okay? So I want you guys to actually try and go through and do number 4. Once you have it, think you have it, or have questions, I want you to raise your hand. Once you have it, think you have it, or have questions, I want you to raise your hand. You're doing a check, buddy. Okay, let's look at this one. Okay, so we made this bottom equation negative. As I spot checked around and as Seth checked too, it looked really good, guys. Okay, so we're going to make this bottom equation negative, and we're going to change the sign. So we're going to make that positive, make the 2x negative, make the 5y positive, and make the 13 negative. Add to eliminate. 2x plus negative 2x, yes.
Okay, so I don't get how you get the plus on the side. I don't get that.
Like how did I get this plus right here?
Yes.
Okay, that plus on the far left. Okay, so do you get how I originally had it as a subtraction? Okay, so we can say we can either add or subtract these two equations together, and we chose subtraction. But then we said, okay, just like up here with this 5 minus 2 and 5 plus a negative 2, we said it's the same thing to whether we're adding the opposite or whether we're subtracting. So I changed this from subtraction to addition.
After you changed everything.
Yeah.
Okay.
And when I change it to a subtraction to addition, I have to change these other signs that follow it, the sign on each of those terms, the x's, the y's, and the constant, because otherwise we can get often confused, okay? Because we technically don't have to change these signs. We technically don't have to change that to addition and change those numbers, okay, those signs of the numbers. What's going to happen, guys, is we have to remember, 2x minus 2x, y minus a negative 5y, negative 5 minus 13, and we just end up getting confused, and it can cause us to make simple mistakes. And so that's why I advocate for changing those signs. So that's a great question, though, on that. So I will change those signs, though, so thank you for asking that. I appreciate that. So 2x plus a negative 2x, that's what, guys? 0, right?
No x.
Okay, no x. What's y plus 5y? 6y. And what's negative 5 plus negative 13? Negative 18. Divided by 6. Y is equal to what?
Y is equal to 3.
Negative 3. Okay, now what do we do after that?
Plug in the y for the top one.
Plug in the y for the top one here, okay?
It's just a y.
So, well, it's just a y, right? 2x plus negative 3 equals negative 5. Add 3, add 3. 2x is equal to negative 2. Divide by 2. And x is negative 1. So negative 1 comma negative 3 is our answer. That's just mean. Okay? Questions on that one, guys? Okay. Now, sometimes we'll see we have to do a little bit more than just changing the signs.
You have to make the number.
Sometimes, excuse me, I'm getting ahead of myself. Let's try this one where we're doing a more open-ended one. We're going to actually create our equations here. Find two numbers whose sum is 64 and whose difference is 42. So how many equations do you think we're going to make based upon what we've been doing this chapter? Probably 2 equations, right? That's probably a pretty good guess. Okay. What are we trying to find here? What's it say? Find 2 numbers.
X and Y.
Okay, we'll probably call them X and Y. We can call them whatever we want. We'll probably call them X and Y. That's how we typically write them. Okay? So, can anybody tell me what one of the equations might end up being based upon our word problem here? Based upon our sentence. Okay? Seth, what are you thinking? Okay, why do you say addition?
Because it says find 2 numbers whose sum is 64.
Okay, so what's the key word that tells you addition?
Sum.
Sum. Sum tells us we're adding. Okay? So we're going to be doing X plus Y. That was obnoxious. Okay? And then what's that equal to? They said the sum is 64. What's is mean? What's is mean in math? Equals. So X plus Y equals 64. Can anybody tell me what my other equation might be? Can somebody knew Reese? Yeah, X minus Y equals 42. What key do you in that it was subtraction?
Difference.
The word difference, right? So we have that word difference that tells us, oh, we're subtracting. Now, is this an equation or is this a system we can solve? Is this one actually already set up very well for elimination? Yeah. We can just add, boop. What's X plus X? 2X. What happens with those Y's? They zero out. Very good. They eliminate. 64 plus 42. 106. You gotta be careful. Divided by 2. What's X end up being? 53. If we need to do it off to the side, we can. 2 goes into 10 5 times. Goes into 6 3 times. How do we go back and find Y?
Plug it into the top because there's no negatives.
Plug it into either top or bottom. Set the advocating for top because there's no negatives. Cool. You might want to choose bottom because they're small numbers. Cool. Either one's a great option. Oof. So we have 53 plus Y, bless you, must rain down after, let's forget. Plus Y equals 64. Subtract 53. Y equals 11. That's a great question. Seth is asking, do we have to put this one as an ordered pair? Well, this time, are we finding a coordinate? No, we're just finding 2 numbers. So this one might actually benefit us more to not have them as an ordered pair. That the 2 numbers are 53 and 11. Those are the 2 numbers. So this one, we have to be very, very special attention, because sometimes it's actually better for us not to write as an ordered pair. We always default to that. But this is the first time we're saying, oh, well, if we're just finding 2 numbers, it might be easier for us not to say they're an ordered pair. Because it really doesn't matter which one we call which. Maybe we can say it's 11 and 53 or 53 and 11. The order doesn't matter like it does in an ordered pair. Because we could have called those variables anything. We could call them A and B. We could call them smiley face and frowny face. We called it Mr. Costle and I don't know.
The first one's Mr. and the next one's Cost.
Oh, the first one's Mr. The second one's Costle. Okay, there you go. Okay, so we could have done some different options for that. Okay, questions on that, guys? Let's look at this next one. I want you guys to try and see if you can tell me what the system of equations will be here. So I want you guys to try and make the system of equations. You do not, repeat, do not have to solve the system. I just want you to write the system of equations. So once you have the system of equations written, I want you to raise your hand. Yeah.
Is it supposed to be 2 times the first number added to 3 and not just 2 times the first added to 3?
Yeah. Yeah, it would be 2 times the first number. So as I looked around, guys, I saw a few people, even going the extra mile and solving it. They didn't have to, but that's great practice, and that was awesome. And the ones that I saw solving it were getting it right, so that was great. So what's our first equation? Chris, what do you have for your first equation?
4x minus 3y equals 12.
Yeah, 4x minus 3y equals 12. Did we have to call them x and y? No. But we could. And that's what our most common things, that's what we default to, right? We could call them, just like we talked about, A and B, Mr. and Costle, okay, whatever. Okay. Our second equation, Justin, what did you have? Yeah, 2x plus 3y equals 6, right? And is this one already ready to eliminate too?
Yeah.
That's kind of convenient. Okay. Questions on that, guys? Okay. Now we'll talk about, I was going to head myself earlier, but now we're going to talk about how sometimes we have to do a little bit more than just subtraction or instead of addition and changing those signs to get them ready to eliminate. So sometimes we have to multiply first. Because we look at these equations in the first example, 2x plus y equals 3, and negative x plus 3y equals negative 12. We say, is everything lined up?
Yeah.
Yep, that's a great check. Okay? Then we say, are we ready to eliminate though?
No.
No. Are the x's the same number in different signs? Nope, they're not the same number. What about the y's? Are they the same number in different signs? Nope. Okay, so we have to say, okay, well, can we multiply one of those equations to make it to where it's ready to eliminate?
Yeah.
What could we multiply by?
3.
We can multiply which one by 3?
The top.
The top one, but what kind of 3 would you have to multiply it by?
Positive.
Negative, because we would need the signs to be different, wouldn't we? Both the y's are positive. So we can multiply the top by a negative 3. What else could we do? Could we do something instead of multiplying the top by a negative 3?
Multiplying the bottom by
Positive 2.
Multiply the bottom by a positive 2. Which one would you guys prefer to do? Multiply the top by negative 3, multiply the bottom by a positive 2.
bottom.
Okay, bottom. Okay, I agree. I would rather choose that. Smaller numbers, less negatives, less sign changes. But we could do the top one by negative 3 and get the right answer just fine. Okay, I want to clarify that. There's not a wrong answer there. Okay, so let's try and multiply this bottom one by a 2. So what we're going to do is we're going to write a 2 in front of that and put a parenthesis there. And we're going to distribute in that 2. And what I'm going to do is I'm going to draw an arrow, and I'm going to write my new equation off to the side here where I have some room. 2 times negative x is negative 2x. 2 times 3y is 6y equals, and what's 2 times negative 12?
24.
Negative 24, haha.
What's funnier than that?
25, okay. Now the top equation, are we doing anything to the top equation? Nope, so we're just going to rewrite it, and we're just going to make sure they're still lined up. 2x plus y equals 3. Now are we ready to eliminate? Yeah, now we are. Put that plus sign there and add these equations up. What does our new equation look like? Ryan, what do you get for our new equation after we add them?
7y equals negative 21.
Very good. 7y equals negative 21. So what should we do now? Divide by 7. Y is negative 3. So we can go back in, plug it into either equation. Now, we want to do either of the two original. Do you guys have a preference between the top and the bottom?
Top.
Probably the top, smaller numbers, less negatives.
Smaller equation.
2x plus a negative 3 equals 3. Add 3 to both sides. 2x is equal to 6. So what's that mean x is equal to?
3.
3. Answer is 3 comma negative 3. We don't have a good reason not to write this as an ordered pair, so we're going to write it as an ordered pair. We're not just finding two numbers anymore. We're going to write it as an ordered pair. Question on that? Okay. If we look at the next one, what might we need to do to those equations? They're lined up, but they're not ready to eliminate. What could we multiply them by? Okay, what would you multiply the top one by if we were to multiply the top?
3.
By 3, because then to make it a 3x and negative 3x. If we were to do the bottom, what would we choose? Negative 2 to make it a 2y and a negative 2y. Do you guys have a preference between multiplying the top by 3 or the bottom by negative 2?
Bottom by negative 2 because then you make all of them positive.
Okay, Seth said bottom by negative 2 because you make the other two numbers positive. I heard some other people say the top. I'm really good with either. What do you say?
I agree with that.
Kenny agrees with Seth. Okay, to mark this monumentous occasion, I'll go with that one then. This might be the only time that happens, so I'll take advantage of it.
Wait, what are we supposed to?
So we're going to multiply this bottom one by -2. We could do either. Now, typically, like I said, I like to write it off to the right side there, draw my arrow, but I'm kind of out of room. There's no cap. Okay, so what I'm going to do is I'm going to do the rare occasion where I actually go to the other side.
But you can't.
Okay, what do you mean?
Why is all the logic?
Okay, what I'm going to do then, okay, not to defy all logic, is I'm going to rewrite it up here where I have room.
Oh, that's broken right there.
I call this a pro gamer move.
Or I agree with that.
Okay. So I'm going to rewrite it. I'm going to ignore that first part was even there. And now I'm going to multiply this bottom by -2. So it becomes 6x minus 2y is equal to what?
Yeah.
Positive 10? Yeah. And the top equation stays the same. X plus 2y equals 11. Now are we ready to eliminate? Yeah, we're going to get rid of those y's. We're going to eliminate the y's. So we get 7x is equal to 91. Divided by 7. X is equal to what, guys? 3. We done yet?
No.
No! Got to plug back into either of the OG2. You guys have a preference? I would choose the top. Yeah, less negative, smaller numbers for the most part. 3 plus 2y equals 11. Subtract by 3. 2y equals 8, or Nate. And y is what then?
4.
And Whitney, how do I write my final answer?
4.
Dope, 3, 4. Thanks, Whitney. Question on that, guys? Okay. We're almost there. Now, sometimes what to say, we have to do what? Multiply both equations. Because if we look at this example, the first example here, we say, well, yeah, we're lined up. We have our x's, our y's, our equals, our numbers, our constants. We're not ready to eliminate, though, because we don't have the same number and different signs for one of the variables. Well, can we make 7 into 5? Can we make 5 into 7? Can we make 12 into 8? No, not without fractions. Can we make 8 into 12? No. So we can't just multiply one of the equations. So we have to figure out what's our least common multiple. What ones can we multiply by? Well, if we were to try and get the x's to the same number, what would be that number? Probably 35. That'd be our smallest one. And so in order to do that, let's think about this. In order to do that, we'd have to multiply the top equation by what?
35.
5 to get to 35. And what would we have to multiply the bottom one by?
-7.
7 to get to 35. It'd probably have to be a negative. So we could multiply, don't write this down. We can multiply the top by a 5 and the bottom by a -7. Let's try if we were to do the y's. What could we get 12 and 8 to, Justin? 24, right? Haha. Okay. So we'd multiply the top one by what? 2. And multiply the bottom one by 3. Probably -3 to change the signs. What would you rather do, guys? Multiply them by a 5 and a 7? Or a 2 and a 3? Probably a 2 and a 3. We could pick either. It doesn't matter which variable we eliminate. But if we can make our life easier, I ask the question, why not? Why would we not try to make our life easier? Does that make sense? Okay, so we're going to go that route. So let's multiply this top equation by 2 and the bottom equation by -3. Bailey, what would my top equation end up being? What's 2 times 7x? 14x. And what's 2 times -12y? Yeah, -24y. And what's 2 times -22? Yeah, negative 44. Very good. And our bottom equation ends up being what, Lauren?
Negative 15x
Mm-hmm.
plus 24y.
Yep.
equals
Yep, very good. Okay, now we notice, are we ready to eliminate now? Yeah, those y's are going to eliminate. Same number, different signs. Negative and a positive, 24, haha. So what's 14x plus a negative 15x?
Negative 1x.
Negative 1x or negative x. Negative 24y plus 24y is 0. What's negative 44 plus 42?
negative 2.
Negative 2. Divided by a negative 1. And x is what? 2. Go back, plug it in to either of the two equations. Which one do we prefer? Probably the bottom. Smaller numbers. 5 times 2 minus 8y is equal to negative 14. 5 times 2 is 10. Minus 8y equals negative 14. Subtract 10, subtract 10. Negative 8y is equal to negative 24, ha ha ha. Divided by negative 8. And y equals 3. So our answer is 2, 3, or x, y. Questions on that? Okay. So sometimes it can be a little more work than what we started with, but is it still that bad? No, elimination gets us to a simpler equation usually. Okay. Sometimes elimination is not very fun, and we'll see why. Okay. But later. But for now, it's not that bad. Now, what were to happen, guys? Would it be as simple and as streamlined if we had an equation like this, maybe? Negative 5x plus 2y equals 32. And then we had y equals 3x plus 4. Would that be as simple for elimination?
No.
No, why not, Whitney? They're not lined up, right? We'd have to get them lined up. So we'd first have to change them around to get them lined up. But what would this be set up for? Not cross reduce. What method did we just learn the other day? Substitution. Would this be set up for substitution? Yeah. Why is that? Y is by itself. We have a variable by itself, okay? So if you have a variable by itself in one equation, it's probably more set up for substitution. But if you have them all lined up already, it's probably more set up for elimination. You could do either method still. Okay? Does that make sense? Sometimes we were saying, oh, this one might be easier than the other in this scenario. This might be a better choice than the other in the scenario. Now, the one's right or wrong, but it might just be a little bit of an easier choice. Okay? So, hint, hint, on a test, if you're given a list of problems and you're said, hey, solve these by either substitution or elimination, you get to choose. It might be a good idea to think about when you would choose each. Okay? You'd want to be able to still do both skills because I'm going to require you to do both. But hint, hint, if you got the choice, you might want to be able to make the easiest choice for yourself. Continuing on, we're going to skip this example there. And we're going to go to this very last example here. These very last two. So we can still come across those parallel lines and the coinciding lines. And I'm going to speed around these two guys just for the sake of time here. I feel like you guys have a pretty good grasp on elimination. So I feel confident in doing these examples more myself and just kind of speed rounding through them right now. So 3x minus 5y equals negative 6. Negative 9x plus 15y equals 13. They're lined up. Multiply the top one by 3. 9x minus 15y equals negative 18. And then the bottom one stays the same. Negative 9x plus 15y equals 13. Add them up. X is eliminate 0x. Y is eliminate 0y. Negative 18 plus 13 is negative 5. Wait, does 0 equal negative 5? No. So what is this?
No solution.
No solution. Those are parallel lines. Whenever we get no solution with the system, that means they're parallel. They never, ever intersect. So anytime we go down to that not true equation, we always end up having that no solution every time we've seen it. The second equation here, or the second set here, what do we guess that one's going to be then?
6.
Probably IMS. Okay, I'm going to multiply the top one by 3, the bottom one by 2 to get those numbers to 6, like Christian was saying. 6x minus 12y equals 18. Negative 6x plus 12y equals negative 18. Add them up. 0x plus 0y equals 0. Hey, well, look, 0 does equal to 0. Is that always true?
Yeah.
Yeah, so that's IMS there, the same line. Coinciding lines. Questions on that, guys?
No.
Okay. So I'm going to pass out our homework now, guys. Okay. One more. 2 more. Should we miss out? Oof. I know. Okay. Now, there are some, we're only doing 8 of these, so let me tell you which 8 we're going to do. So I want you to do numbers 2, 4, 6, 8. Who do we appreciate? Okay. Nate, okay. And then we do 16, 18, 22, and 24. Haha. Okay. So you do 2, 4, 6, and 8, 4 on the front. And then 16, 18, 22, 24, 4 on the back. So how many are we doing total?
8.
8 problems. 8 problems. Not 20, 22. Yep. Questions on that? Okay.